Good afternoon, students. Today we're going to look at some solutions to practice 6 problems. It's page 34, 35 in book 2 of your ma1026 booklets, of course. So, and this is simplifying what we call a compound fraction. Some people call it a complex fraction, compound rational expression. So it's basically a fraction over a fraction, using, of course, variables. So I have 3 here. Let's look at a couple for sure. See if we can get all 3 done fairly quickly. Now, normally I would like to, I'm going to move this one. Hold on now. I'll move this one out of the way over here for a second. We'll put that back after. Just see how much room we have. So normally when I write these, I like to work horizontally and vertically. So I like taking the expression and writing it like this. There's the top. Now understood to be over 1, so I put the 1 in. And then divided by, so basically that's this line right here, translating to divide by t over 1 plus 2t over w. Okay? So let's have a look at how we'd simplify that. So that's the first step. I usually tackle it that way. Again, it's purely habit of mine. If you don't prefer to work fraction on top of the other fraction, you can do that as well. And there's several techniques to do these problems. So have a look at other techniques if you're not completely satisfied with this technique. Okay? Now, again, we need LCDs when you're adding, okay? So here we are adding these 2 together. We need LCD for that between W and 1, and the LCD is W, right? Which means I have to take this one and multiply by W over W, right? This side here. So on top I'm left with T plus 3TW all over W. Now repeating that on the same side, on the other side, of course, I again have the same LCD of this one. LCD between 1 and W is W. So now I'm multiplying this one by W over W. So I get TW plus 2T all over W. Now, as you can see, I still have a division sign in between, right? And of course what that means is I have to multiply by the reciprocal, correct? So we end up with T plus 3TW all over W multiplied by, okay, W over TW plus 2T. Now it looks like we're not going to have room for number 14, so I'm going to delete number 14 and do that in a separate video, okay? So you can watch that in another video if you want. Now let's continue with this one. Now I see a GCF of t on top, so I can factor t out, and I'm left with 1 plus 3w, right, all over w multiplied by w, and I see a GCF of t as well here on bottom, leaving me with w plus 2, correct? Okay, now because everything's factored and multiplied in the middle, we can cross cancel, of course. So this w here can cancel with this one, and this t up here can cancel with this t right here, leaving me with 1 plus 3w over w plus 2. Or if you'd rather have the variable first, we could write the top as 3w plus 1 and w plus 2, but you don't have to do that, right? So your final answer is right here, 3w plus 1 over w plus 2. Now that's one technique, and again, a technique that I use to do these types of problems. So again, if I tackle 11, watch the first thing I'm doing. 1 over x squared minus 1 over y squared, okay, divided by 1 over x squared plus 1 over xy. And again, choose your LCD for each one, simplify, and then because it's division, change the multiplication, and so on. So the LCD here is x squared y squared in the first one, isn't it? Okay. Now the LCD here, that means I have to multiply this one by y squared over y squared, and this one by x squared over x squared. Okay, so that'll give me y squared minus x squared on top, and on bottom I have now the common denominator of x squared y squared. You only need to write it once, because these are both the same, x squared y squared, x squared y squared. Okay, repeat that process on the other side. Again, my denominator this time, my LCD, if you use this method, is going to be x squared times y, right? We make the denominators the same using x squared times y. So this one I have to multiply by y over y. In order to get x squared, I got to multiply this one by x over x. So on top I get y times 1, which is y, plus 1 times x, which is x. And on bottom I have the common denominator, x squared y. Now, remember, this is, of course, dividing. So the first thing I'm going to do is change this to multiply and flip the back fraction, which is x squared y over y plus x. This one stays the same. Now I'm also, because of lack of space here, going to do one step right away here again. Hopefully you did notice, but this is the difference of two squares. So that top one can factor. Right? That'll factor to y minus x, y plus x. And the bottom, of course, is just x squared, y squared. Now that we have everything factored, we can cross cancel any common binomials or common numbers, terms, whatever. So let's see what, okay, I see a y minus x here with this y plus x and y plus x. X squared here with this x squared up here, so they can cancel as well. Oh, and I got y and y squared. So one of the y's down here, so I'll just cancel the square out with this y up here canceled, leaving me with simply y minus x over y. Okay? And again, if you want to complete these, you actually should state where it's undefined. Oops, not w in this case, of course. It's y. Y cannot equal 0. That will make the denominator 0. So if you want a complete answer, there it is right there. And here, of course, you should have put down w not equal to -2. That would make that denominator 0. But that's okay. We're concentrating on simplifying the rational expressions, right? So there you have it. That's solutions to number 10 and number 11. Okay, on page, I think it's page 35 of your text.